are going to elaborate total internal reflection. So total internal reflection, in short TIR, when light ray travel from denser to rare medium, it bends away from the normal. We all know that, suppose this is denser mu d and this is rarer medium. So when light rays goes from denser to rare, it move away from what? Normal. And if light rays goes from rarer to denser, this is denser medium and this is rarer medium. So when light rays goes from rarer to denser, it moves towards what? Normal. Okay. So when light ray travel from denser to rare medium, it bends away from the normal. If the angle of incidence is increased, angle of refraction will also increase. At a particular value of angle, the refracted ray subtend 90-degree angle with the normal. This angle of incidence is known as critical angle. If angle of incidence further increases, the ray comes back in the same medium. This phenomenon is known as total internal reflection. What actually I want to tell all of you is that this is denser medium and its refractive index is mu d, and this is denser medium. Denser medium, and upside it is rarer medium, right? And we are sending light from denser to rarer medium. We are sending light from denser to rarer medium. Of course, its refractive index is mu r. Light ray will bend away from normal. This is angle of incidence. If we will increase angle of incidence, here we are increasing angle of incidence. In that case, angle of refraction will be like this. So for a particular angle of incidence, if refracted angle will be 90-degree, then that angle of incidence will be known as critical angle. Okay, there are certain conditions for total internal reflection. What actually total internal reflection? This is critical angle, and at critical angle of refraction is what? 90-degree. And if we will further increase angle of incidence, in that case reflection will start place and 100% reflection will take place. Since I am calling it 100% reflection, that's why it is named as total internal reflection. But before total internal reflection, for this and for this, certain refraction was also happening and certain fraction of reflection was also happening. Okay, but if theta, here it is theta, if theta is greater than critical angle, theta c is critical angle, and about critical angle I have already stated that critical angle is that angle for which angle of refraction is what? 90-degree. That means refracted ray grays parallel to interface. This is technical term. In this case, for this case, total internal reflection, total internal reflection will take place. In short, it is known as TIR. there are certain conditions for total internal reflection. I am just going to brief them. Conditions for what? TIR, total internal reflection. First, angle of incidence. Angle of incident should be greater than critical angle. Critical angle, that is I greater than theta c. First, and second is light should travel from denser to rarer medium. This is also mandatory condition. Light should travel from denser to rare medium. For example, glass to air, water to air, or glass to water. Glass to what? Water. Okay. Now, uh, I am drawing certain figures to elaborate all this stuff. This is normal, right? And downward it is tensor medium. Suppose its refractive index is mu d, and at upward it is rarer medium and its refractive index is mu r. So of course mu d is greater than what? Mu r. And if we will send light from denser to rarer medium, it will go away from normal, right? If this is angle of incidence, and if we will increase angle of incidence, then a stage will achieve, for which suppose we are sending light here, we are sending light and we send it for a particular angle such that refracted angle became what? 90 degree. So in that case this angle of incidence will be known as critical angle. And for angle of incidence greater than theta c, if you are sending light greater than theta c, this was your theta c and this is I, and if I is greater than theta c, in that case 100% reflection will take place. That's why it is known as what? Total internal reflection. In this case, reflection plus refraction both were happening, but in this case only reflection is happening, and that's why it is said total internal reflection. So here I is less than theta c, first case, here I is equal to theta c, and here I is greater than what? Theta c. And downward is rarer medium, all this is downward is denser medium, this is denser, and upward is what? Rarer. Downward is denser and upward is rarer medium. So to happen TIR, total internal reflection, light should send from denser medium to what? Rarer medium. So now we are going to suppose we are saying this surface xy, this surface xy, this surface xy, this surface xy. So we are going to apply Snell's law at boundary xy. Okay, so here in the refractive index of denser medium is mu d, and refractive index of rarer medium is taken as what? Mu r. So mu d sine theta c. We are dealing for this case because this is the case under our interest TIR, critical angle. So we have sent light at critical angle, and critical angle is that angle of incidence for which angle of refraction is what? 90 degree. So mu r sine what? 90 degree. So from here you can easily get critical angle. So we will have to understand the basic definition of critical angle. We can easily find out critical angle. So sine theta c is mu r upon mu d, and as we know mu is inversely proportional to lambda, inversely proportional to v. So from here we can also conclude that sine theta c is equal to first mu r upon mu d, and this is equal to vd upon vr, and this is equal to lambda d upon what? Lambda r. So this is also a very important relation. Now we are going to elaborate through certain example. First is when light ray travel from mu, refractive index, refractive index medium to air, then mu r is equal to 1 and mu d is equal to what? Mu. So sine theta c is always mu r upon mu d, and here mu r is 1 and mu d is what? Mu. Okay, and proportional to lambda, which implies, because lambda is inversely proportional to mu or mu is inversely proportional to lambda from Cauchy's relations, which implies theta critical for red will be greater than theta critical for violet. This is also important aspect. So for TIR, for TIR, TIR stand for total internal reflection. I should be greater than critical angle, and of course sin I is greater than sin theta c, and of course sin I is greater than 1 upon mu, because sin theta c is what? 1 upon mu. So it implies what? Mu is greater than 1 upon sin I. Suppose when ray travel from travel from glass to air, always remember sin theta c is always mu r upon mu d, never mu d upon mu r. Sin theta c is mu r upon mu d, and in this case refractive index of air is 1, so this is a rare medium, and mu d it is glass and its refractive index is 3 upon 2, and it is approx 42 degree, which implies this is critical angle. And for TIR, at critical angle TIR not taking place, rather greater than, for angle of incidence greater than theta c, TIR take place. So if I will be angle of incidence will be greater than 42 degree, then TIR will take place. Okay, and if I will be less than 42 degree, then refraction will take place. Partial reflection will also happen there, but prominently refraction will take place. Next example I am going to put forth before you. When they travel from water to when they travel from water to air, sin theta c is always mu r upon mu d, never mu d upon mu r. And refractive index of rare medium, which is air, and it is 1, and mu d is of water, and it is 4 upon 3, and it is approximately 49 degree. So if I will be greater than, so this is critical angle, and critical angle is that angle on which refracted ray grazes parallel to boundary, and angle of refraction is 90 degree. But if we desire to have TIR, for that purpose, to achieve that purpose, we will have to maintain angle of incident greater than critical angle. So if I will be greater than 49 degree, in that case TIR will take place, and if I will be 49 degree, in that case what will happen? Refraction. Okay. Next example I am going to cast before you. When ray travel from glass to water, in that case sin theta c, which is always mu r upon mu d, and here mu r, the role of mu r will be played by 4 upon 3, and mu d, it will be 3 upon 2, and this is 8 upon 9, approximately it is 63 degree. So of course, if I will be greater than 63 degree, in that case TIR will take place, and if I will be less than 63 degree, what prominently will happen? Refraction. Okay. One question comes frequently, that a point object, this is a very popular question, is situated at the bottom of tank filled with a liquid of refractive index mu up to height h. it is found it is found light from the source come out of liquid through a circular portion above the above the object, then radius and area of circle. Situation is like this. This is this is object which is h height below. This is B. This is its center. This is A, and its radius is R. So since light rays only the boundary of light rays is this. That means if we have sent light at this point, that rays grazes parallel to upper interface. So of course this angle is what? Critical angle. This is critical angle. Okay, because for this angle of refraction is 90 degrees. So what is happening to the right, the same thing will also happen to the left. So it is again getting parallel to top interface, and of course this is also what? Critical angle. For theta greater than, if we will send light which is more than theta c, of course this is I and it is greater than theta c, in that case TIR will take place. So outside rays, before this outside rays, possibility of outside rays was to come at B, or the possibility of light rays from B was to go outside. But any rays which is beyond point A, and this is point P, will not under this area, will not fall under this area. This is this is like a question that a face is placed here. Suppose a fish is placed here, so what outside world the fish will see? So only those area fish will see from where light, there is a possibility to come light at B, and any light rays which is coming from this point, actually that rays are coming due to TIR. Okay, so of course the outside world will be only that area on which rays are passing through this circle. So now it is simply geometry. Sine theta c is equal to r upon root under r square plus h square, because it is perpendicular upon hypotenuse. Sine theta c, this was your critical angle. So sine theta c is equal to perpendicular upon hypotenuse. This is hypotenuse. Okay, and we know sine theta c is equal to mu r upon mu d, and upside mu r is air and downside mu d is mu. So it is 1 upon mu. So if we will equate 1 upon mu with r upon root under r square plus h square, we will, if we will proceed it, 1 upon mu square is equal to r square upon r square plus h square, which implies mu square minus 1 r square is equal to h square. So from here we are going to get r is equal to h upon root under mu square minus 1, and once we get radius, so area will be what? Pi r square. And if we do talk about tan theta c, tan theta c is perpendicular upon base, and that is r upon h. So of course radius is what? H tan theta c. So angle which the eye of fish makes, suppose here is a fish, so angle with which eye of fish makes is 2 theta c. This is 2 theta c, theta c to the left and theta c to the left. So 2 theta c means 2 into 49 degree, because it is case of water and it is 98 degree. This angle does not depend on depth of liquid. Okay, so once again I just want to tell all of you that this is fish, and question will be asked that what is the radius of outside world this fish can see. So through this mechanism, through this process, we can easily find out uh, radius and all those things. So thank you so much to all of you